Hi everyone, so we have another AMC 12 problem. So we are looking for the largest value of the y over x for real numbers x comma y will satisfy this equation. So if you do now this is actually equation for a circle. You can graph like the circle and see how we can go from there, or you can just choose maybe some other tool to apply. But what I will do is using some algebraic approach. Okay, so since like we are looking for the the largest value of this fraction, so I'm gonna call this guy, let's say k. Okay, so and then if this is the case, the y value will be kx. So because I do have two variables, I like to deal with only one, so I will try to get the k from there. So if I plug this into the original equation, so let's do that. So the x minus 3 square plus y minus k, and the y is kx, okay, minus 3, and is equal to 6. So now I can expand those by square root binomial, or you can just write x minus 3 two times and then multiply them, which is okay, but I'm going to use a square root binomial. So that will be equal to x squared minus 6x plus 9. And then if you expand this, you will get the square of this guy, which is k squared x squared, and multiply this negative 3kx, double that, so you will get negative 6kx, and if you square 3, you will get 9, and this is equal to 6. Okay, again, if you didn't get these on your first step, so you can just write x minus 3 times x minus 3 and expand them, which will give us these. And let's simplify a bit. So this is a square term, this is a square term, and if we pull these together, so you will get 1 plus k squared times x squared. And then you got negative 6x and negative 6kx, so I can pull as negative 6 plus 6k x, and then that's 18 on the left, and then 6 on the right. So that will be 12 on the left. Okay. So now, like we have to like take a look at what we have. So we are given that the y and x is real numbers. So if those are real numbers, the fraction of those is also real, which is k is real. But this is a quadratic equation in terms of x. So in order for us to get a real solution, then the discriminant of this should be also positive number, or at least 0. So let's take a look at the discriminant, so which was b squared minus 4ac. This has to be larger than or equal to 0 in order for us to get a real solution. Or so the b is this coefficient, so let's plug that. So negative of 6 plus 6k, and then this is our b. So minus 4 times a, which is this guy, which is 1 plus k squared, and times c, which is 12. And this has to be larger than or equal to 0 in order for us to get a real solution. So if you expand this, so since this is squared, this minus will be positive. So we are going to just square this guy, which is 36, and plus, and that will be 36 times 2, which is 72k, and plus 36k squared. Again, if you do have issues with this, like make sure you remember this, a plus b square equals a squared 2ab and b squared, and that's square root binomial. I just use that here, and I use here again. And if you square this guy, 1 plus k squared, and 12 times what is 48, so I will get negative 48 times square of this guy minus 4ac. Actually, we don't have to square this one, right? So there's no square. Okay, because the discriminant is b squared minus 4ac. This is b squared. This is 4. This is gonna be a. A is this guy. So a times c. C is 12, so which has to be. So 1 plus k squared. This has to be larger than or equal to 0. So if you simplify a bit, you know, if you multiply this by this, you get negative 48, but there's a 36, which will make minus 12. And then negative 48 times k squared, negative 48k squared. There is a 36 of those also, which will make minus 12k squared, and then plus 72k. And then this has to be larger than or equal to 0. So since we can divide by 12, maybe minus 12, so let's divide by negative 12. So k squared minus like 6k and plus 1. Since we divide by negative, so we're going to change the direction. So that should be this. So again, this guy will be smaller than or equal to if you want to get the real values, right? So, but you are looking for the largest value. So for this k, then maybe we can find the k values that will make 0, because that will be largest value, because other than that, everything will be smaller. So then we have k squared minus 6k plus 1 has to be 0 to get the largest number. And you may use the quadratic formula at this point, or you can use completing square. So if I use the completing square, so you will get k squared minus 6k, and divide this by 2, which is negative 3, square that, so will give us 9, but I need to subtract the same thing, so we can get no changes. So that should be equal to 0. And then these three terms will give us a k minus 3 squared. This is negative 8 if you move it to the other side, so that should be 8. And take the square root, so the k minus 3 would be plus or minus 2 root 2, because square root of 8 will be this. Add 3 to both sides, so you will get 2 root 2 plus 3. So you could just say, okay, k is equal to 3 minus 2 root 2, but this number is smaller than this number, so we are looking for the largest, so which is going to be choice A. So if I choose like the k squared minus 6k plus 1 lesser than 0, so I will get smaller values. That's since we want to get the largest value, I just make that equal to 0. And then when that is equal to 0, we have two different the k values. We just need to choose the larger one. And that is the answer. So you can do this question a couple other ways, but I'm going to leave it for you to explore that on your own. I just want to use the algebraic approach. Okay, I'll see you in the next video.